So let's start. From Copilot to GenUI. So you already seen the Flutter Credit Agricole app today during the accessibility talk. So today we're going to talk about the same app, but from the perspective of mobile platform team and AI journey in the Flutter app.
Hello everyone, my name is Piotr Pawlicha. I'm from Credit Agricole, from DigiTribe. I'm also a product owner of technical squad, which is responsible for CI/CD processes, tooling, and developer standards.
And I'm Mateusz, you already know me. And I'm here because I've started this project with Piotr and Credit Agricole's team 5 years ago, I guess. And this is the app that's not just an app. It's the app from Flutter.dev official showcase. This is the app that you've probably seen already our talks about it, about large banking app, about Flutter in banking. We had a lot of this talk where it was at a lot of conferences, and then we stayed quiet for a bit. So now we're coming back after a couple years. It's still there. It's still maintained and it's still developed. It was one of the biggest Flutter apps ever created, especially in the banking domain. Like to just show the scale, we had more than 250 people on the team. Then it was 30 Flutter devs across 16 squads, and we were both in the mobile platform team, which is where we started the app, the architecture, standards, and everything, right? But today we're talking about from Copilot to GenUI. So let's start our journey, right?
Yeah, so we started from basics, chat and inline compilations. We chose the Copilot, GitHub Copilot, because it has been recognized as a leader in Gartner's Magic Quadrant for a code assistant in 2024 report. It was the second year in a row. GitHub Copilot is widely used tool with over 20 million developers in 77,000 companies. And it's truly understand the market and continuously expand its offering with new features and models from biggest players. It seamlessly integrates with popular IDEs. But the most important thing from enterprise perspective is that the Microsoft is a trusted partner and it delivers a service for European market in compliance with regulations and guarantees that it doesn't use a processed code in any way, including model training. This is how our roadmap looked like. We started 1 year ago with approval of our security office. We selected participants from whom we collected feedback. We set up teams and working guidelines, but a significant amount of time was taken up by procedures, documentations, and approvals. To summarize, it took us a full year to make this solution compliant and approved. And yeah, this is a reality of enterprise AI adoption. One of the key challenges was code ownership. We were concerned about the situation where AI-generated code being blindly accepted, coming back from production as a bug no one could fix. And excuses like, it wasn't me, it was the AI. Our answer, every piece of code had still to be signed off by an engineer, and specific name should serve as it's a sign of personal responsibility. It's like Rolls-Royce or Boeing engine factories, a nameplate with a signature even when robots help with the build. Every merge request requires approval from another engineer, also human, and final merge request is performed by a human stream maintainer. And automation handled the rest. I mean, unit tests, vulnerability checks, linting. We have also feature flags and access control for faulty functionalities if needed. This is how we implemented it in practice. Human gateways didn't tell us how the tool was actually being used. So we added a questionnaire to every merge request. It's developers self-report whether AI was being used, how it would, what it was used for, and to what extent. It's kind of real data on the scale of Copilot usage across the project. What do developers say? In interviews and conversation, they estimate that Copilot speed up their work to about 20%. And comments like, I can no longer imagine working without Copilot have emerged, but also sometimes it hallucinates, it doesn't follow our coding standards nor design system. So this is a subjective assessment. So we added heart measurements, Copilot telemetry, and we found that mobile team has reached 37% of inline completion acceptance rate, which means every third suggestion from Copilot is taken to the code, and this result puts them in the top 25% globally. Another example is using Copilot chat in automation test team. They reach 66% of acceptance in chat. This is a multi-technology and exploratory work, so the chat fits perfectly. We have different teams with different characteristics, but both effective and above market benchmarks. So the tool works. We wanted more. We wanted more because inline completion and Copilot chat are reactive. It's a productivity boost, not a workflow transformation. So we started asking, what if Copilot could generate whole screens or functionalities fully aware of our architecture or coding standards? That would be a shift from inline completions to agentic development. And that's why we started a POC with LeanCode, AI-assisted development.
Right. So first, of course, you had to start with Copilot and all the stuff. People got used to AI, and then you know how fast and quickly like AI progresses. So there were already agents, and we thought, yeah, how to approach that, because we had a lot of actually of doubts, because it's a huge project. It's kind of a project. This mobile app is about, I don't know, 2 million lines of code, I think, 70 packages. Like in the previous talk about Credit Agricole app, it was a slide with 300 design system components or something like that. So it's already hard because we were scared that it's either too expensive, like every prompt, or the context would be too large to fit into the model. So we said, okay, let's start modeling this new workflow with a POC. So we selected 14 production quality screens. What it means is that they were already ready for development, but nobody taken up the issue, like nobody taken up the actual tickets from the development. So we branched off from that point in time, so that AI wouldn't have the real code, because we knew from some statistics that, for example, Claude models can look into the Git tree. It can search other branches. So even if on your branch this feature is not there, but you have that on other branch, it's very likely that the Claude model would pick up already done code from other branch. It would totally ruin our experiment, right? So we took screens that were ready for development but never actually implemented. So what we built on top of Copilot, two class of things. One class is, of course, rules and skills. But what was important is to make AI speak Credit Agricole lingo. So in our app, of course, like you can imagine, because many of you are also from enterprise environments, we have a lot of very our stuff. I would say, like you look at the code and it happens only in our code base, because we have our own navigator like new. We also have our own navigator. We have our own design system components. We have our own way of translations, our own way of connecting with Figma, our own way of doing some special metadata comments, so that then we can do some specific tasks in the CI/CD pipelines. So a lot of stuff that are very Credit Agricole specific, and the model cannot know about it, because we just figure it out ourselves. Again, another thing is the API, right? Some specific API, some specific way of working with that API, some specific API client. We generate contracts from the API. We have to teach the AI the way that it's being generated, and so on and so on. Additionally, we wanted to use not the most expensive models. So not only Opus, because we thought that if it's so, maybe robotic is the wrong word, but if it's so predictable, because we have already predictable architecture, predictable documentation, predictable tooling, if it's so predictable for humans, maybe we can make it so predictable for AI that we can use mid-size models, cheaper models, with a great accuracy. So we started with these rules. As you can see, examples of them for qubits, for UI, for linting, for data layer, localization, even golden tests, because we have a large golden test coverage and unit test coverage, and how to map Figma to the specific component. But what's important here is that in Copilot, you can also make it a custom prompt. It's a tool that Copilot can actually ask you some questions and follow some workflow. So every time the developer in Credit Agricole takes some feature or screen, it has to use some specific ticket number from Jira that's also on Figma, and also connected to localization, so that all the systems are connected and you can track that this is connected to this feature and this screen. And you can make Copilot ask you about it. So every time you start a new feature, it will ask you about this specific Credit Agricole thing. That's very, very nice, because you can forget about it and it still will remember it. So it starts with asking, okay, which squad are you in, for example? Is it like account squad or transfer squad? Okay, I know. So if you're in transfer squad, then this is your identifier. What's the ticket? Okay, I can see. Now I can connect to Jira. Now I can connect to Figma, and so on. So that's also a very, very interesting thing that we learned about Copilot. And custom MCPs, custom tooling, of course, Marionette to close the loop, like we mentioned. Of course, Figma MCP, like Anton mentioned, and 1,5, and Lucas from Widgetbook. Figma MCP, of course, because we start by getting the context and screenshots from Figma. But then we realized that if we have 300 or more design system components, we cannot just let AI find it itself, because it's too risky in terms of context. So we needed a way to literally tell it, this Figma component is this exact file, this exact Dart class. So we have our own design system MCP for the Credit Agricole design system that can search constructors and widgets and map the Figma components from the Figma MCP to the exact implementations. And again, the same is with the API. We have all the contracts generated, so we have a custom MCP to let it know from the the Jira ticket, from the description. It can navigate to the exact API endpoint that you might want to use in this specific feature. And of course, we wanted to measure something because it's so hard in AI world. So we tried, first we tried using Copilot without the rules and without the MCPs. So you can see on the left, it generated something that looked pretty much similar. This is the funny part, that it actually, many times it can generate code that looks similar, but in terms of the UI, but when you look at it, it used a lot of material stuff. That's pretty much forbidden because Credit Agricole is not based off material. It's its own self-contained design system. And it forgot about using design system spacing, about the design system icons, about App Navigator, Credit Agricole Navigator, about our specific routing, about our localizations, and so on and so on. And with rules and MCP, it was very much one shot. I know that it's everyone tells that, but it's really, really hitting very, very often. It's hitting. Most of the times it's just hitting because it's predictable and all the stuff is very standardized. One more thing that was actually, we have also a Credit Agricole CTO in here, and he asked us about, during this experiment, about the context. So how much of the context tokens are actually used. And we were amazed because thanks to using the MCPs that actually cut a lot of stuff so that AI doesn't navigate to that stuff and doesn't put that into the context, we observed that we had a whole screen, a whole feature, and we just used, in the Copilot, we just used, I think, 200,000 or something like that tokens. So we didn't have to compact the context during the features, which was very, very important for us. And after the experiment, during the experiment, we got 2 times faster, but it's hard to say, in the long run, because it was just an experiment. But now we started pushing the workflow to all the developers in the main app, and also trying it out in another app. So we're gonna measure it, and we're gonna try some measurement strategies, because it's also hard to do that, to have some more information for you in the future. But what we already see about the speed is that standards held up, which is very cool in terms of reviewing and all the process. But also that onboarding is much easier, because onboarding junior developers, they get a real boost, because they can just focus on delivering business value. And what this unlocks, this is the third part. So the predictable architecture, the design system, this is something that's already been talked today. Even on the Google I/O talk about Flutter, they mentioned that for their generative UI, what was important was predictable design system and architecture. So I think we all got to the same point. So thanks to that, we could proceed with the agentic development. But then we thought, okay, we already have all the parts. We have all the MCPs, index design system, agentic stuff. We could actually try out some experiment with generating UI, because why not? So I started it, and here's the demo. It's nothing official. It's actually something that I just did before the talk. So as you can see, here's the prompt, like, I'd like to transfer 100 zlotys to my mom. And it actually generates, you'll see, a form. That's actually a form from Credit Agricole design system, and it's already filled with recipient name and how much money should I pay. Of course, it's without real data, because it was just to check the mobile app capabilities and all the MCPs that we have in the mobile app repository. But it's maybe it will open the doors for some more agentic experiences in the future. Who knows, right? Thank you very much. That was our journey. And now it's your turn to do yours. Right, and maybe we will talk again in the future to let you know how it went.
Thank you very much.